Hello again. Right, well, in the last episode of this, we set up an Arduino with some code to read all of these pins and to constantly throw the output out to a serial monitor. And that's fine, it threw out a whole bunch of zeros and ones, and that was working, that was great, but it didn't leave me much the wiser in terms of what was happening, and so there's some improvements that I would like to make to our code to try and make it work a bit better. And one of the things is the Arduino is throwing out data all the time, far faster than the computer is providing data. And what would be quite nice is if we could just throw out one line every single time the clock went. So we can apparently do that if we connect our clock signal to a particular pin on the Arduino. Apparently pin 2 can do this. So we will have a go. Let's go back to our code and I'll explain what we're going to do. So here is our code. Now the problem is that this loop is void loop, simply runs and runs and runs and runs and runs and runs and runs. Okay, so actually what would be better is if we could put this in its own little function, which we'll call void, we'll call it on clock. Okay, like that. Okay, so what would be better is if we could take all this and stuff it in to the on clock function. Okay, let's just try and make that a tiny bit neater. Okay, let's take, so now void loop, sure, it might run and run forever, but it's not going to do anything. The only thing it's only going to ever print it out if we call this function void on clock. So now all we need to do is to work out how to call void on clock when the clock goes. Now we're going to use a thing called interrupts, which is basically when the computer is, or the Arduino is told stop what you're doing and run this piece of code immediately. And that's all we're going to do. So up here, what I will do is I will put in, and we're going to define a variable called clock, and we'll define that simply as the number 2. Okay, and that just means that instead of writing 2 every time, I can call clock, so it makes it slightly clearer what I'm going to do. So again, the other thing we're going to have to do is we're going to have to, down here, we're going to say that our clock is going to be an input, because it is. We're not outputting anything from the Arduino. So pin mode, okay, and we're going to say clock inputs. Okay, so now it knows that the clock is an input, and then this is the line of code which is going to interrupt the program every single time the clock goes ping. Okay, so if we're going to attach an interrupt, and we have to say digital pin to interrupt is clock. So when that happens, we're going to run on clock, which was the thing about printing out our zeros and ones, and we'll do it on the rising edge of the clock. In other words, when it goes from low to high. So with a bit of luck, let's see if that will compile. Okay. Well, I've misspelt digitan pin. A digital pin, presumably, would be helpful. Let's see if that works. It compiles. Let's put it onto our Arduino. Now then, let's bring up the serial monitor and see. So we're now not getting masses and masses and masses of zeros and ones all the time. And what I'm hoping is, if I start up my computer, let's just clear it. Okay, so every time I push this, it should produce. Okay, well that's good, it is, but it's only ever producing zeros. Not sure why it's doing that, but potentially that's something we can explore later. Okay, good. So we've defined our clock as pin 2. I tell you what, something else would be useful is if we could also read the read-write pin as well. So let's get ourselves another jumper, and we'll stick that into the read-write signal, and we'll stick that into number 3. Okay, and let's just power down the computer for the moment. Right, okay. So now what I want to do is zeros and ones, not all that easy to read. So ideally, I want to read, do you remember we talked about turning binary into hex? I want to read it as hex. But the trouble is, all we have done down here in our onClock function is we've just spat out zeros and ones. It's not a 16-bit number and an 8-bit number. It is 16 zeros and ones in a row. Okay, just like if you write the number 4 and then write the number 7 next to each other, it doesn't necessarily mean 47. It could mean 4 and then 7. So the first thing I need to do is, for this thing, I need to, I'll tell you what, let's go up here, and we'll also define ourselves a read-write pin while we're here. Okay, so let's define, where's my hash sign? There it is. Define read-write. Okay, and we'll define that as pin 3 because that's the pin I plugged it into. Then I'll be able to use that in a bit, and I'd probably better also tell it that read-write is also an input. Let's take that back a step, and we'll tell it that read-write is an input. Okay, right. Now then, let's go down to our onClock thing. Now, before we do anything very much, we are going to have to set up a variable which is long enough to put in all the numbers that I wanted to put in. So it's a bit like, I don't know if you remember BASIC, but you need to define a variable before you can use it. So at the beginning of void onClock, let's go with character output, and that's our variable, and we're going to tell it that it has 15 spaces, which it should be long enough. Okay, so now we've got ourselves a character output, and then we're going to let's see, for the address we will call it unsigned integer, and we'll call that address. Hold on, I've called this address. I'll go back and call this addr. There we go. So I'll call this addr. I'm not sure if it may actually just be fine with the idea of a lowercase and uppercase being different things, but who knows. Okay, as I say, I didn't pretend I knew what I was doing. So we're going to start with a number which is 0, okay, called address, and then after we've printed out all of our zeros and ones, okay, we're going to say it is, we're going to shift it 1 to the left, okay, and then we're going to add in the number bit. Okay, so what we're going to do essentially is, this is in the thing that's going around 16 times, okay, it's going to chuck in the number into address, and it's going to shift it to the left, add in the bit, and again then it's going to do, then it shift it to the left, add in the next bit, shift it to the left, add into the next bit, shift it to the left, add in the next bit. Okay, so with a bit of luck that should do it, and then we're going to do the same thing down here as well. So in fact, this is quite a good opportunity to see if we can put in a number called data lowercase, and it's different from data uppercase. Let's have a look and see. By the way, it's unsigned because it's always a positive number, so we don't need to deal with negative numbers. Okay, so unsigned integer data is 0. Okay, after we've printed the bits, we are going to go data equals data. Now hold on, I have left out a bracket, haven't I? I think it needs to go there. And let's see, put that bracket in there as well. Okay, so yeah, that plus bit. Okay, again, I don't know if you need to put semicolons at the end, but I'm going to put semicolons at the end each time anyway. Right, so what we should now have, once we've been through this 16 times and been through this 8 times, we should now have a number that is called address that has all of the zeros and ones properly in it. And we should have a number that is called data that has all of the zeros and ones properly in it. Okay, I think what we're going to do is we're going to format, do you remember we created a character called output there? Okay, well we're going to format it, so the sprintf, okay, is output, okay, and then let's have a look. We'll have 3 spaces, and then we're going to tell it that we want a 4-digit hex number, so that is %04x. Okay, a couple of spaces. We're going to have 1 character for the read write. Okay, so we'll just have 1 character for the read write. Okay, and then we will have a 2-digit hex number. Okay, and then we're going to tell it what all of those numbers are going to be. So the first number is going to be address. Okay, the second number is going to be reading the read write pin. Okay, however, again, that's going to return true or false, and I don't want it to return true or false, I want it to return read or write, so we're going to return, if it is true, it will return the character R, and if it's not, it will return the character W for write. Okay, and then the final one, there's the 2-digit hex number, is going to be address. Okay, and then when we do the print line, we'll print output. Okay, so what this should do is format this in a way which you get a 4-digit hex number, a read write, a 2-digit hex number, and then print that out. And with a bit of luck, that will now give us hex numbers instead of zeros and ones. Let's have a look and see. So will it compile? It will compile. Will it go up to the Arduino? It will. Let's have a look at the serial monitor. Let's open the serial monitor a bit further, and then let's turn the computer on and see what happens. Okay, when I pass the clock, okay, you can see that we are getting whatever is happening on the address bus, whether it's reading or writing, and whatever is happening on the data bus. So that's simpler to see, which is excellent. Okay, but what it isn't is any more use in terms of working out what on earth is going on. Can you see the processor is trying to write out to the address bus at that point, the data bus at that point, so it's trying to throw data out, it's trying to read data in, and of course nothing's connected to it, so it's reading nonsense. So in the next episode, what we're going to do is we are going to try and give it a signal that it can understand, and see if we can get the thing to behave itself a little bit better. So that's what we'll do next video. I shall see you then. Goodbye.